Welcome to our session. My name is Rohini Gaonkar. I'm a senior developer advocate at AWS. And I have Suman Debnath, who's our principal developer advocate at AWS. And in this session, we will be talking about building a managed analytics platform for your e-commerce business. Now, before we get into all the technical details of building this platform, I do want to talk about something that is so integral to our day-to-day shopping. I mean, how many of us have spent tens of minutes, if not hours, on an e-commerce platform trying to find things that we need? Anyone? Oh, great, just not me. And things we actually don't need, but maybe we just want, right? And and that's what e-commerce platforms are about. But then there's another side, right? There is this buyer side where you want the best product, the best price. You want useful recommendations as well. I think my voice is moving here and there. But you want the best product at the best price. You want good, useful recommendations from the e-commerce platform. And category you've been looking about, you want those useful recommendations because you want to do your best purchase. Like, no one's saying that I just want to buy for the sake of it, right? And then there's the other side, which is the seller side. Now, the seller or an e-commerce business, and for the entirety of this session, us, we, you, are going to be the e-commerce organization. So there's the other seller perspective, where the seller wants to make sure that the end customer who's buying the platform has all the fancy deals that they want. They want to give the best and they also want to do that at the right page. So for the e-commerce business to be successful, they need to offer all of these features, and they also have to offer, if not hundreds or thousands and millions of products on their website. And for them to be successful, all they need to do is to build a scalable analytics and data pipeline. So, and that is what we learn today. Now, I understand there are a lot of different variables and different criteria for an e-commerce website to be successful. They need to have a good user interface. They need to provide, they need to have being mobile friendly. They need to provide multiple payment methods, or they need to provide better hassle-free shipping and returns for their end customers. But for the sake of this session, we are not focusing on all of that. We are focusing on providing the better products, deals, and recommendations. So let's look at some of the common use cases that will apply to the majority of e-commerce businesses out there. The first is about brands' popularity. As the e-commerce platform, we might want to know which are the most popular brands in the different categories that we are selling. Like, we want to know what are the best brands for mobile phones, for furniture, for laptops that you're selling on the platform. This will help us understand and prioritize where should we invest, what more should we do for marketing these products better. There could also be scenarios where a product has been sold a lot many times, but it doesn't really have any reviews on the platform, so people don't know that this product is actually doing good or not. So we do want to know these different use cases with respect to our platform. The other is definitely talking about a journey. We want to know different buying patterns of our customers. And a very, very common problem or common pain for a lot of e-commerce customers is abandoned carts. Customers add products to their carts, and they don't really end up buying those things. Now, there are a lot of reasons why this is happening. It could be that they have been working, and they just want to surf and add products to the cart, but they got distracted by a ping by a colleague. Or maybe they wanted to buy a product, add it to the cart, and they saw your shipping is very expensive. So they said, hey, costs are too high. Maybe this is not a good deal for me. Or it could be out of stock. Or they're just researching. People use e-commerce platforms just to research and see who's giving the best deal or the best price. Or maybe, just like me, before they sleep, they just want to surf on the e-commerce platform and see, hey, what are the good deals today? So there could be different reasons why people are abandoning carts, and we want to know why they are abandoning carts as well. So depending on these different scenarios, maybe we can provide better discounts, or we say, hey, if you buy this product in the next 15 minutes, we'll give you a discount coupon. Or maybe send them an email saying, hey, you have an abandoned cart. Do you want to go and finish the checkout process? Or we want to give you more discounts on your shipping. We are giving free one-day shipping if you sign up right now. We want to know these details as well. While I'm here, this is an important issue, so I do want to give you a real-world example. So as a solutions architect for AWS in my past life, I worked with a lot of e-commerce customers as well. And one of my customers, their problem was that people were adding stuff to their cart during a sale, but they were not purchasing it. On doing a lot of analytics, they realized that after adding products, when people were actually trying to buy them during a sale, products went out of stock. There were not enough products that they had. So what this did was a little innovative, and I thought I should share it with all of you so that if you want to go and build an e-commerce, maybe you want to add certain ideas like this. So what this customer did was, they have these loyalty customers, right? These customers are paying maybe a small amount, but they are paying an amount to be a loyalty customer and keep coming back to this platform. So before the sale, let's say the sale starts on 1st, okay, 1st of November. So before the sale actually started on 1st of November, what they did was, for these customers who are their loyalty customers, 48 hours before the sale, they created something like a special cart, okay? They created a cart and they said, you as a loyalty customer, you get to see our sale prices before anyone else in the world. You can add these products to your cart before anyone else in the world. If you add them now, we guarantee that you will get this product if you buy it from there. And as midnight strike, this special cart was then converted into a cart which the customer just has to say, hey, buy this, pay using this, and that's it. And they provided guaranteed deliveries because now this customer is doing this for them 48 hours. Now, as an e-commerce business, it was beneficial. First, they came to know what are the products people are most interested about, right? And they can then talk to their industry and get more of these products if required. The second, from an application perspective, if it's a sale, as an e-commerce, and you say that midnight the sale starts, you see a lot of high surge in the demand, right? Because everyone's just going and trying to see, hey, what's the sale price? What's this going on? But for them, that was actually lowered because their paying customers were actually doing it 48 hours before the actual sale. So that also helped with their management of their scaling as an e-commerce platform as well. So we can think about these different things if we know the right reasons for doing different activities. And of course, the third is knowing our customers. I mean, it's obviously important to know our customers because different demographics do interact with online shopping very differently. A teenager would shop very differently as compared to an elder person or my mother. So our sales and marketing teams would definitely want to know more details about how our products doing, how many people are logging in, how are customers interacting with the platform itself, so that if they want to maybe provide certain discounts, or they want to do certain marketing activities, or they want to create seasonal sales, they would actually know what are the best days when they should be actually doing these sales. Does Friday, Saturday, Sunday work for you, or does Tuesday to Thursday work for you for doing a sale? So a lot of analytics is required for them to make these different. Let me give you an example, right? If, for example, a lot of your customers are buying certain products very regularly, for example, we are buying tissue rolls every 3 months. So you would know that customers very regularly. So what you would be doing is giving them, let's say, hey, if you subscribe for this, we'll give you a discount coupon. And every 3 months, this customer is staying on your platform. Now, that is not just one, but thousands of customers that you have retained on the platform every quarter. Now, that's a very big deal for an e-commerce organization, is to keeping customers on the platform, right? Or for example, recently I was buying a TV, so I realized this is something that people do with TVs as well. Like some TV is trending because a vlogger talked about it. What you could do is you could say, hey, I cannot give discounts on the TV, but let me do this. I'll get a third party, I'll give you a combo deal. You can get an insurance, get an installation, you get shipping, everything through the third party, and this is a combo deal that I want to give it to you. So there are a lot of different things that you can do if you know your customers. So as you can see, a lot of this is related to time. Now, a lot of e-commerce companies understand this, that the longer that it takes for you to take time, the longer it takes you to make that decision, the data actually has become stale over the time. You need to make these decisions right now, like as soon as possible, to be able to provide to a lot of these customers who are now shopping online. So if you see that on the x-axis, you have is time, and on the y-axis is actually the value of the data in decision making. And in today's session, we are going to look at two scenarios. One is the batch, the traditional batch processing, and the other is online or near real-time processing as well. So when you think about real-time or near real-time, we mean that we can take online time-critical decisions. For example, you can send offers or you can send coupons in real time to increase sales and reduce your cart abandonment. But for traditional batch, it's okay if you take minutes or hours to actually process that amount of data, because there you're processing data of days and weeks and months and even years. There we are trying to understand, hey, for example, how did we do the first week of January 2022 this year to last week of January 2021? How did we do this? How was the business doing? Are we doing better on our sales? Do we need to change strategy in the way we are doing our sales as well? So let me summarize what we are actually building in the next 40 minutes. First, we are going to build an end-to-end data engineering pipeline to simulate the e-commerce workload and the use cases we just discussed using an open source data set. Second is that for the online processing, we are actually looking at a very simple but frequently asked scenario of DDoS or fraudulent transactions attack. For example, let's say a customer is making multiple payments and multiple orders within few seconds and minutes, which is not really something that a lot of our other customers do, or which is not really a normal buying pattern for us. And the third is definitely batch processing. We will look at analyzing and creating dashboards for some frequently required business critical decisions or insights that our different departments need. So let's quickly look at the architecture before we actually get into the demo. We are hosting this application on AWS as, let's, for an example, assume that a lot of our customers are in a particular region, and that's why we're building this application in one of our AWS regions. We also have an e-commerce application. Obviously, we are not building that. For the sake of it, please assume there is an e-commerce application, which is our source where the data is actually coming from. Now, there are a lot of transactional and clickstream data. Everything is coming from this. But for the sake of this session, we are actually assuming that it's sending streaming data into our application. Next, we capture this streaming data using Amazon Kinesis data streams. Now, data streams can actually capture data from multiple sources. It can be an AWS service, it can be mobile applications, even your sensors or logs can actually send data into Kinesis data stream. The data is actually stored in the order that it was received for a set duration of time, and you can actually replay that data n number of times while it is being stored. Then we can have a lot of consumers from that Kinesis data stream. Now, in our case, we are actually using Kinesis data analytics that can read and process the streaming data in near real time. For the online processing, example, we are looking at DDoS or fraudulent attacks scenario. So from the analysis, for the analysis, we are actually using Apache Flink, which is an open source unified stream processing and a batch processing framework. We will be also using Glue to discover and evolve the data schema for that stream. And when an attack is going to be identified by the processing, that data is actually going to be pushed into another Amazon Kinesis data stream. This stream, if there's data in it, will actually invoke an AWS Lambda function that will simply trigger an SNS notification to your team and store this information into a scalable NoSQL database like Amazon DynamoDB. And with this, I think I'll hand it over to Suman to take us forward.
Sure. Thanks so much, Rohini. All right. So just to summarize where we are now in this architecture is we are basically taking the online shopping transactions, and it's coming to Kinesis data stream. And then we are processing that with Kinesis data analytics using Flink. So what we are essentially doing is, and what you will see in the demo, is we are taking that data, and in this Flink application, what we are going to do is, let's say we will take last 10 seconds transaction, and we will run some SQL query to find out which are the users has made more than, let's say, 10 transactions in 10 seconds, which is quite unnatural for any human being to do, right? We cannot add 10 products to our cart in 10 seconds, right? So we are going to do that analysis using Flink, which is an open source project from Apache, which is one of the top 5 project in the Apache Foundation. And we are going to use SQL for that, but you can always make use of Python or Scala. And once that is done, then it will trigger a Lambda function, and then you can give some notification to the user, and you can do any back-end job in the downstream. Now, if you think about this, we are processing this data in this Apache Flink layer. Now, let's say after 1 month or 2 months or 3 months, you discover that the developer who has written this Flink application has made some bug. Right? So now we will obviously fix that bug, but you cannot go back to the time and reprocess that data because we are not storing the raw data which is coming here. So that is what we are going to do in the first place, and that is a big data 101. Like before processing the data, whatever data that you are getting from your application, you should save it somewhere without doing anything. So what we are going to do is we will take that Kinesis data stream, and we want to store it persistently in some data lake. And that's why we are going to use Amazon Kinesis Data Firehouse, which can take that stream and save it to Amazon S3. So now this is a raw data. So in this case, even if you discover some bug at later point in time in Flink, you can still have that raw data. Right? So once the data is in S3, what you can essentially do next is you can make use of Glue to do some processing, like converting that data into a more efficient format like Parquet, which is the format that is used in any big data processing. Or you may like to add new columns on your incoming data stream. So all of that you can do using AWS Glue ETL. Now, if you think about this, at this point in time, we have Glue and we have our data on S3. So what you can do now is you can now query that data using Athena. Because you have the schema in Glue and you have that raw data on S3, now you can use Athena to query. So as Rohini mentioned earlier, you can run some query to find out the top line products in your e-commerce business, the bottom line products in your e-commerce business, which product is selling more, what is the customer pattern, and so on and so forth. Now, as a data engineer or a data scientist, you can always do this query and get the results. But for our leadership team, like CTO, CIO, and VPs, they may not like to see all of that queries. So they would like to see some dashboard. And that's where you can make use of QuickSight, which will take the data from Athena, and you can make beautiful dashboards. So that's the whole thing that we are going to build now in the demo. And this is a repo, which you can always make use of. And the slide decks are also there in the GitHub repo, so you can always take a look later on. But before we jump into the demo, as Rohini mentioned, we are at reInvent, and we have, we have a certain amount of time. So we don't have the e-commerce application built here. So we don't have any website or mobile application which can actually, stream that data. So what we are going to do is we are going to use a Python script, right? And what this Python script is going to do is it is going to use a CSV file, and I'm going to show you that CSV file. And that CSV file comprises of all the transactions. So things like if a user is adding a product to the cart, that will be one record. A user is buying a product, that will be another record. So in this first 3 lines of code, what it is doing is it is actually reading that CSV file. And then, since we are doing a simulation for online processing, we need to have timestamp, right? Without timestamp, we cannot figure out anything. We cannot detect DDoS attack and all of that. So since this is a simulation and we are using a CSV file for that, we need to add a timestamp. And that is what we are going to do here in this line number 17, where we are just adding timestamp to that each record. And once that is done, we are just pushing that data to Kinesis data stream. So this is just for the sake of the demo. In the real world, you will not have this Python script, but you are going to take this data from your application. So maybe a mobile application or web application or whatever. All right, so let me go to the demo. No matter how much you prepare, it will always log out when you start the demo. All right, so we are going to use an Cloud9 instance. I have created a Cloud9 instance here, which we are going to use. I have opened it, but I'm sure it will go, yes. So let's reload it. How many of you use Cloud9? Okay, quite a few. So Cloud9 for you, for folks who are new to Cloud9, Cloud9 is basically an IDE on AWS. So you don't have to carry your laptop and all of that. So you can, it will give you a development environment on the cloud, right? So you can use any system and you will get an environment like this. So let me just open it up. So this is the Cloud9 environment that you will get. It's quite similar to any of the IDE that you might have seen. So this is the Python script that we have, and this Python script is going to stream the data to Kinesis data stream. Now, one thing that we need to have first before starting this script is we need to create this Kinesis data stream, right? So let me show you how we can create. So you can come to Kinesis dashboard, and then you can come to stream. And if you see here, we have 2 streams. Okay, so for now, you can ignore the stream 2. We will look into that, what is stream 2. But this is the stream 1, which we are going to use, where that Python script is going to write the data. So let me go here, and we can simply start that. So what it is doing now is it is reading that CSV file, and the CSV file looks something like this. It contains the event type, it contains the product ID, catalog ID, brand, and if you see this, the event types are only 3, like adding a product to the cart, purchasing a product, or viewing the product. Okay? So now the data is coming to your Kinesis data stream, right? So now, just to keep things, let me just show you this. So at this point, where are we is we are sending the data to this Kinesis data stream, right? So our next thing is we have to do is we have to create a Kinesis data analytics application. So before we go there, let me show you what this application is going to do. So as I just mentioned, we are going to use SQL to build this application. But before we create that application, Kinesis or Flink need to know the schema of the data that is coming. And for that, we are going to create a table beforehand. And the schema of this table is exactly same as the CSV file that you have seen. The only addition here is line number 12 here, which says that we are telling Flink that whatever data you are getting, just store it in memory for the last 10 seconds. Why 10 seconds? Because we are doing a detection of DDoS, right? So we are telling Flink that store the data for last 10 seconds, and then we are going to write that data to another Kinesis data stream that is going to be stream number 2. And in this, what we are saving is just the user ID and the number of transactions in that 10 seconds. And how we are going to write? We are going to write like this. So if you see this, I'm going to show you in the console. But this is very small. But if you see this, we are just saying that check for number of counts of transactions in that last 10 seconds. If it is more than 10, then just write it in this second stream. So the second stream will contain only user ID. That means the ID of the user whom we feel that might be a bot or something like that, and we will just write there. So the idea of this is before we create this Flink application, we need to have two tables created. This is the first table for stream 1, another table for stream 2, right? So let's go back to our demo. So how we are going to create that Flink application. So if you come to Kinesis, now there are different ways that we can create a Flink application. I'm going to show you how you can easily create a Flink application using Kinesis notebook. So if you come to Kinesis dashboard and come here at data analytics, and you will see I have already created this application, but I'll show you how I have created this application. So there are different ways that you can create this application. You can create it in your system, in your laptop or any virtual machine, and put all the code on S3 and deploy that. But we are going to use a Studio notebook, which is nothing but a Zeppelin notebook. So if you have, how many of you worked on Jupyter Notebook? Yeah, most of you. So Zeppelin is similar to Jupyter Notebook, but here you can run Scala code or Java code or SQL and all of that. So all this code is present in the GitHub repo. So I already have uploaded a notebook. If you are trying it out, after this reInvent, you can click on import the note, and you can upload that Zeppelin notebook. I have already uploaded, and this is the Zeppelin notebook. So if you see this, still now we have not created this application. We are just in the testing and development phase, and you can think of this as a Jupyter notebook. But the only difference is we are running some SQL query. So this is the first table that we need to create, which we have seen in the slide, and then we have to create the second table for second stream. And if you see here, in the first table, we are mentioning from which stream to take that data from, and we are saying that take the latest data. As the data comes, take that. And then we are setting the region and the timestamp format, which is a standard ISO 8601. And for the second table, we just need user ID and number of transactions per watermark. So that watermark is nothing but that 10 minutes of window size. 10 seconds of window size. Okay? So once these two tables are created, what we can do is we can run this query, and this will run your Flink application. And this is where we are just checking if the number of counts is more than 10 in that last 10 seconds, just make an entry. But since we are doing, we are at reInvent, our data set is very clean. To get that trigger, I have added that count is 1. That means any user who is doing 2 transactions in that last 10 seconds, will be considered as a DDoS attacker. Okay, this is just for the sake of the demo. All right. So now once you do all your research and development and testing using this notebook, it's very easy to build an application out of it. As long as you are into this notebook, your application is not deployed. right? It's just like in Jupyter. We are just testing it out. We are getting the output from each cell. So the easiest way to deploy this is to first build a Flink application by clicking here. So it's very simple. All you have to do is you have to just click on build. And what it would do is it will package that whole code that you have in this notebook. It will put that on S3, and you can then deploy that application. So I have already built that application. And next thing that you need to do is come here and then click on deploy that application. That's all, right? So it will create an application with this name. The name would be exactly same as the notebook name with some random string towards the end, right? If you see this, A9HY, right? So I have already created this, but you can just click on deploy, and it will deploy. So let me now show you, once you click on deploy, what you will see. If I come here and come to application, you will see the application running here. And if you notice, the name is exactly same as the name that we have just seen. Now, this application is up and running, and we can see that data we are pushing from our Python application. So now, since this is a Jupyter notebook, we can actually check if we are getting the data through that Flink or not, right? So we are just running an update query. So if you see this, it has already detected the schema of the data, event time, event type, product ID, and all of that, which we have created in the schema, right? And if you see this, the data has started to come. And if you see a scattered plot, you will see that how many users are actually viewing the product or purchasing the product. As of now, you see that most of the users are just viewing that product, right? So all of this you can do, you can use Zeppelin Notebook to see that. All right, so now just to give you some context, where are we now? So we have created this Kinesis data stream. We have created another Kinesis data stream and created this Flink application. And now we have to trigger this Lambda function, right? And that Lambda function will store all those users which are fraudulent in this DynamoDB table, right? So let's go to the demo. OK, so now if you go to Lambda, so now if you come to Lambda function, you'll see there is one Lambda function running here. If I click on that, you will see that the trigger is Kinesis. Can anyone guess? This trigger should be from stream 1 or stream 2? Can anyone guess? Stream 2? Yes, that's correct. So if you see this, the trigger is actually coming from stream 2, because this is where we will have all these fraudulent users' details. Now, I have also created a DynamoDB table, and that is there in this environmental variable, right? So now what we can do is we can go to DynamoDB, and come to explore items, and this is the same table which we have used in the Lambda function. And if you see this, all these users are fraudulent, basically. If you see that we have a user ID and the number of transactions per watermark is more than 1, because that is what we have mentioned in the code. Okay, so all good so far. Now let's talk about batch processing, because we talked about the online processing, how we can capture users who could be a DDoS, who can be a DDoS attack. So now what we can do is we need to, let me just switch back. So far, what we have done is we have completed this whole chain, right? So I've not shown you SNS, but it's there in the Lambda code, which will send an SNS notification. Now let's talk about this part, right? So where it will read, the Kinesis Firehouse will read the data from the stream and write it to S3, and then we will go to QuickSight. So So now, if you come to Kinesis, and there is a Firehose. So I've created this Firehose application stream, and it's very simple. If you want to create this, you can just click on create, and you have to select the source. So as I said, source could be either Kinesis data stream, or you can use a direct put. So you can select this, and destination, we are using S3, but you can always write this data to multiple different services, like Redshift, OpenSearch, and so on. So I've already created this delivery stream, and it is actually writing the data to S3 bucket. So now what we can do is we can go to Glue and query that data. So for that, we need to go to Glue. And if you come to tables, you will see that there is one table here, which is in Parquet format. And now we can do a querying. So for querying, we need to use Athena. So either you can search Athena service from the search bar, or you can click on table data and click on proceed. It will open up the Athena console. So if you see this here, we can query that data, and we are able to see the real-time data with timestamp and the event types and all of those other details, right? So now we have the raw data. What we can do next is we can run a lot of queries. For example, let's say we want to see what are the different types of events that we have, right? So we can simply run event type, and we can count how many users are buying the product or just viewing the product, and so on. So if you see this, there are roughly around 900,000 purchases, and there are a lot of views and people who are just viewing that product, and there are a lot of people who are adding that product into the cart. So you can run all those queries here, but now for our leadership team, we need to project this data into a dashboard, right? So now we can open up QuickSight, right? So let me open that QuickSight. So this is the QuickSight dashboard. So I'll show you, how I have come to this page, but this is something that you can get automatically when you load that data. So I'll just increase the font size. So if you see this, we can see that the top movers of these, during that time, so we use just 1 month data, you will see that Scarf is one of the top moving data product. Then we have Kitchen Flyer, and so on. So it's just getting refreshed. So there are something that interesting that you can, and I'll highly encourage you to look into, is insights. So when you click on insights, you will see all those recommendations here, like top 3 movers, bottom 3 movers, and so on. So I have not manually ran any SQL query to get these information. This information came automatically after I loaded that data. And I'm going to show you how you can load that data. But this dashboard, I just, it just took me 10 to 15 minutes to come to this dashboard. And you can see, bottom line products like jacket, and then fryer, and all of that. So based on this, you can take some decisions that who are the vendors who are supplying this product, and you can maybe, revisit the contract for future, and so on and so forth. Now you can also see some interesting things, like how many products which are category-wise, which were sold in last month. You can also see how many products people are adding. So if you see this, people are adding more amount of products into their cart than they are buying, right? So this is something that you can get. Also, you can get some trends. So this is very interesting. So you want to, in the initial slides, Rohini mentioned about some deals, offers, and all of that. So as a company, before you launch any deal, you would like to know what is the best day and time for those launches, right? So these kind of data can help you to come to those conclusions. So if you see, this is pretty interesting. If you see this, on Sunday, people are adding a lot of product into the cart, but they are not end up buying, right? So this happens a lot, right? At least in my case, it happens a lot when my wife adds product on Saturday and I delete them on the Sunday morning. So this is quite natural, right? So these are the things that if you now connect back, it actually happens in our day-to-day life. So if you see these kind of pattern, you can figure out which is the day people buy most of the product. And if you see this, it's Sunday. So it might be great if you push any deal or any discount on Sunday morning or so, or maybe Saturday evening, and depending on different geographies, because this is a singular data. You have to connect this with multiple other data, which you have, and take some decision. And also, if you are into the data science world, this is a Sankey diagram where you can actually see day-wise how many people have added the product into the cart, and let's say on purchase on every day, right? So you can see that purchase on Friday is very thin, whereas adding the product on Friday is very high, right? So all these things you can visualize into this dashboard. Now let me show you how you can come here. So what I'll do is I'll go to the home page, and the first thing, this is the dashboard I have. The first thing that you need to do is you need to have the data set. So you can come here and click on data set and click on new data set. And for us, the source would be Athena, right? Because that is the service that we are going to use. And you can give some name. So let's say demo 123. You can check the connectivity, and then you can create a data source. And you have to make sure that your quick site is in the same region as your whole application, because otherwise you may wonder that why your database are not showing up. Because a lot of time what happens is all of my resources which we have created is in US East 1, and my quick site in US East 2. So here you will not see all those databases here, right? So that means that you are in the wrong region. So I have this database, and now if you see, we have all those tables automatically, got detected by QuickSight. So now if you select, this is our table, if you remember, activity Parquet. And now if you edit and query, you will see that whole data, right? So if you see this is the data which we have seen in Athena, but now in a tabular format here. So now what you can do is you can save and publish. Now one thing I would like to share here is, which, when I was trying to do this demo, I realized that this data, if you see, this is a date-time format, but it is in string format, right? Because that is how the data is saved in my Glue catalog or Athena. Now, what you can do is you can not only just upload the data as it is, but you can use some custom query. So let me show you that. So I'll just cancel this and come to data. I'll do the same thing, create new data set, click on Athena, let's say demo 123, create a data source. And now, what I'm going to do is, I'm not going to select this table, because if I select this table, it will load the data as it is. But what I can do is, I can use some custom SQL query, right? So let me just copy paste one SQL query, and then I'll show you what we are doing there. So let me just copy this. So what we are essentially doing here is, we wanted that field event time as in timestamp, right? Not as string. So what I'm doing here is, I'm telling QuickSight to not only load the data as it is, but just cast that and change the data type to date and time. And that is what I'm doing here. And now if I just preview that data, you will see that the timestamp, this column, is now of date time format, right? So this is the flexibility that you will get in QuickSight, that you can either use the data format as it is there in the Glue catalog, but also you can run custom queries. All right, so once that is there, what you can do is you can just run, click on save and publish. And you can click on visualize. So now you can, click on any of these columns, and it will automatically create those charts for you, right? So you can, if you see in the bottom, you have different types of charts which I have used, but essentially you can make use of this dashboard to create charts which we have seen in the first place on this dashboard, right? So similarly, you can create multiple charts based on your requirement. Okay, so that is something that gives you the ability to visualize your data that you have, in your data lake. And if you remember now, we started off with S3, right? So all the data is dumped on S3 by the firehose, and then we started to build an analytical application and dashboarding on top of it. All right, so let me go back to our presentation. Okay, so before we go over to the next slide, just to summarize, we started with online processing from Kinesis data stream. We used Flink, and we used SQL to do that processing, but you can always use Python or Java or Scala for that. And we used another stream where the filtered data was there, right? This is stream 2, and this contained only the user ID and the number of transactions of that particular user in last 10 seconds. Now, it could be 10 seconds, or it could be 1 minute. It's up to you. In fact, since we tried to mimic DDoS, that's why we ran that query. But it could be any other use case, like recommendation engine. Like if the moment a user adds a product, let's say a laptop, you would like to recommend maybe a laptop cover or maybe an adapter. So all those decisions can be taken by this application. And then it will trigger a Lambda function, and it will do the downstream processing, right? It could be a recommendation, or in this case, blocking that user. And then in the batch processing, we took the data from Kinesis firehose, saved it on S3, and from S3, we used Glue to catalog that data, and ultimately created a dashboard out of it. So before we end, I'll hand it over to Rohini. She will just touch base on the sessions that you may like to attend after this. Yeah.
Thank you. So if you are interested to know more about how you can do these activities that we talked in brief, in detail, please do attend these different sessions. There's also a workshop if you're interested to do all of these things hands-on, and all the code, amazing code that Suman actually showed you throughout the demo is on the GitHub platform. So you can go ahead, experiment with it, play with it, do the things on your own. And with that, I do want to thank you all for attending the session. I hope that we all learned something exciting in the session, and next time you're building an e-commerce application, you would like to understand how things work behind the scenes. And with that, we'll open for questions. If you have any questions, there's a mic here. Please feel free to come here, ask those questions. If you're shy, we are still going to be here in this room. Feel free to come and catch us there. We'll wait for a minute if anyone's coming here or we are getting off the stage. Thank you, everyone.